Hello, everybody. Thanks for joining our app modernization demonstration. My name is Hank Scorpio. I work at the Globex Corporation. We're a global conglomerate with many businesses. One of those businesses that we have is a retail business that's very vital to our overall company health. In that retail business, we have a very important application. It's the retail application. This handles our inventory, orders, and customer engagement. So it's the lifeblood of our business. It's been around since the mid-2000s. It's an N-tier application. You can see here, it has a monolithic middleware tier. It's using Apache and an Oracle database as a backend. All of this is running on VMs on vSphere. I want to tell you a little bit about the history. In the mid-2000s, we started to experience some challenges, and we've experienced them up until this day, where code commits took a long time to get into production. So our feature development was very slow. We've had a series of code deployments that actually took the app down once. These failures, when they would happen, would take hours to fix. So oftentimes the app would be down for long periods of time, which is leading to millions of dollars in lost revenue. And then we also have difficulty handling transaction volume because it's a scale-up application, and we just hit the scaling limits. And during peak times, we have to actually drop transactions, unfortunately. So we decided, because of this, to start to strangle this monolith to improve those areas. We identified 4 services in it: a gateway service, a customer service, an order service, and an inventory service. So the first step we took, this was about 7 years ago, was we decided to start to strangle out the customers and the order service, the gateway and the order service. And so at the time, we heard about this new platform called cloudfoundry, and it seemed pretty cool. So we decided to start deploying our applications and writing them in Spring Boot on cloudfoundry. And so we took our gateway service and order service and began to refactor those into separate services. We also developed a new modern front end for this running on cloudfoundry. Of course, our Postgres database for our order service, we moved to a Postgres database as we did this. It was really challenging. All the logic in the Oracle database that was there caused a lot of problems while we made this move. And the Postgres database still has to live on VMware because cloudfoundry couldn't handle state. Unfortunately, we realized that cloudfoundry is not the right choice of platform since there's so much momentum around Kubernetes. So we decided to deploy a Kubernetes environment for our last service, the inventory service. As we strangled out the inventory service, we decided to use Quarkus. We'd seen it, and we're really excited about how it's just a little bit friendlier and has some real nice benefits from a cloud native standpoint over Spring Boot. So we decided to use Quarkus, write this inventory app, and kind of pull it out of the N-tier application architecture. And we did this successfully. And the nice thing about Kubernetes is we were able to bring our Postgres database along as well. Unfortunately, the developers who were developing this on Kubernetes, they did this entire deployment manually, meaning that it's the ability to redeploy this application is quite difficult. And so our ops teams in production are not going to allow us to promote this into production unless we automate this. So this is where we're at right now. It's pretty cumbersome. We have 3 different platforms. We have still our N-tier application moving slowly. We have a dying platform in cloudfoundry that we don't know what to do with the services on there. And then our Kubernetes deployment isn't necessarily we're not deploying the application in the way that we want to, in more of a GitOps fashion. What we want to get to is this, where all of our services are running on Kubernetes. So this way, we get all the benefits of Kubernetes across the entire application, where we can roll back, roll out in an automated way. We could take advantage of bin packing, horizontal scaling, all those things. In conjunction with this, we want to use a GitOps philosophy to really improve our software delivery performance around the key metrics that we're looking at in the middle here: lead time for change, mean time to recover, our change failure rate, and our deployment frequency. And finally, we want to simplify operations by doing this, in that we will have everything on one platform. And then we can begin to measure our software delivery performance using something called Polaris, which we'll touch on later. So the question is, how do I get to this? And for that, I've invited the Konveyor team here. They've been knocking on my door for a while now, asking to come meet with me about my retail app. Ramon, thanks for joining us. What do we do to start to modernize this app?
Happy to be here. So first of all, James, what I would do would be to run an assessment on all your application portfolio to find out what will need to be changed in order to move your application portfolio towards Kubernetes. So right now, I would say the main candidate for having some troubles when moving to Kubernetes because of the containerization process will be the customer's application. So we will have to analyze the source code or the binaries for that application to find anything that might prevent it from running in containers and change whatever is required. And next one. Once we have found whatever needs to be changed, we can change it right away in an assisted fashion.
Nice, nice. Okay, so that'll help me start to figure out what's wrong with that app and figure out how to containerize that. Great. What about this Oracle database? It's pretty heavyweight, but we're kind of scared to change it.
So yes,
that sounds scary.
Sorry. Yeah, the Oracle database is one of those workloads that require quite some effort to transform. I mean, we don't have currently Oracle images to put them in containers, and even if you put them in containers, the operations are very different. So there are many workloads that you don't want to transform just at once, immediately. So you want to bring them next to your containers because you need them next to your containers to behave properly and to be able to manage them. So what we're going to do is bring them as a VM into Kubernetes and keep it as a VM in there so they could run with the rest of the containers and leverage the benefits of having these VMs in Kubernetes as another Kubernetes object.
Nice, nice, Miguel. That sounds awesome. So I'll be able to run this right by my containers and get all the benefits of Kube. Cool. That's interesting. All right. What about Ashok? You were telling me about how you can help me with my cloudfoundry services. What can we do there?
Absolutely. Your team was very interested in looking at moving the cloudfoundry applications to Kubernetes. And to do that, you have to create a few artifacts like the YAML files and the configurations required to get the most cloud-native deployment. And we have this Move to Kube project in Konveyor, which can help you create all those artifacts for you.
Nice. Thanks, Ashok. And finally, this inventory service, Marco, you were telling me about the Crane project inside Konveyor. How do we automate this and get this over so we can move it to production?
Exactly. So this was like, it's already running on Kubernetes, but it was manually deployed with all kinds of hard-coded data inside our deployment. So this is what we want to clean up using Crane and then push that to Git so that we can then follow now our new GitOps practices and have this automatically deployed from development to QE to production. And also transfer this database, make this agile as well. So this large database of all our products can follow those deployments and then also be promoted from dev to production.
Nice. You know, this, I mean, it sounds good on paper when you look at it like this, but I tell you, it's hard to believe that it could be that easy. So you're going to have to prove it to me. So I think the first step we had was actually taking that customers app and actually assessing it and analyzing it and refactoring it to run in containers, right, Ramon?
Okay, so yeah, let's start by getting into Konveyor Tackle. The entry point for Tackle will be the application inventory, and it looks like your architects were proactive enough to load up your whole application portfolio into the app inventory. It can be done in many ways, but for example, it can be done using a CSV import. So I'm guessing they did it that way. And
nice,
now you say something about the.
Oh yeah. Sorry. We better filter out that Doomsday device. Nobody's supposed to know about that application yet.
Yeah, absolutely. So the idea behind the app inventory is to be able to classify the applications, the whole inventory in the way that you might want. So one of the ways that we have is the business services. I can, for example, choose the business services, the retail, and the application list gets filtered. Also, another way to classify applications is by using an extensible tagging model that comes with the tool. So, for example, in these applications, we have chosen to use tags that describe the technology stack for each one of the applications. For example, for the gateway microservice, we have an application that is made with Java and Spring Boot. If we get into the inventory microservice, we have a Java, Quarkus, PostgreSQL application. And finally, if we get into the legacy customer management application, the one that we see might be a bit problematic, we see that it is a Java, Tomcat, Oracle application. But as I told you, this tagging model is extensible. So we created a new tag type related to the different custom libraries that you have in-house. And this application seems to be using a custom configuration library.
Ah, great. So that's good. So we can actually start to assess any of the risks with this specific app using tackle here?
Exactly. So since this is the one that comes from a more legacy platform, I think that's the best candidate to start with the assessment and try to figure out if it fits inside containers or not. So for that, we will be using the assessment functionality or the assessment feature from Tackle. So we can choose the application and start an assessment. So I know you are a very busy person, Mr. Scorpio. So I already had a conversation with your architecture team, and I already have the answers for this assessment. But nevertheless, we will do a full run through just to let you know how this thing works.
Yeah, great. Let's see what the assessment looks like.
Okay, so first of all, we have the stakeholders view. We have to choose who was involved during this assessment, just to be able to keep track who provided the actual answers to the questions, just in case we need to get back to them during the migration project. So it looks like we had a conversation with someone called Simpson. I don't know if you're familiar with him.
Yeah, he's a little bit of a difficult employee, but he's a good guy.
Okay, so moving on. Well, let me explain you how this whole assessment is done. So the way we see the assessment in this tool is a questionnaire-driven approach in which we will be tackling the different areas related to the application landscape. And by that, I mean things like technology, application lifecycle management, operations, all the different things that have an impact on how an application behaves and is managed. And the idea behind the assessment is to know how suitable an application is for it to be running inside a container. So we can go through the different questions that we have: application architecture, observability, cross-cutting concerns. And once we have answered all the questions, we can start with the review.
Nice. Okay. So I see it identified. It looks like I like the chart up there. So it's telling me there's a few high and medium issues here, huh?
Yeah. Well, the idea behind the review screen is to show the different risks that have been detected during the assessment. So the tool is able to detect a series of risks related to the containerization process out of the answers that are provided during the whole assessment process. So let's take a look at this risk to try to figure out what needs to be looked at. So here's the list of risks. The list of risks. Let me rearrange this thing. So there seem to be one high risk and a couple of medium risks. The high one is related to the service discovery. So it seems to be using some sort of hard-coded IPs or things like that. It makes sense. It comes from a legacy platform. So for example, I see the application uses a database.
Yeah, so maybe like the JDBC driver config. Okay.
Exactly. So that's something we can easily fix by changing the configuration files. There's also something related to how mature your containerization process is, and well, that's exactly why we are here and why you called us and why you invited us to this thing. And finally, and for me, the most important thing to take into account is related to how the application is configured. So it seems like you're using multiple configuration files in multiple file system locations. Does that ring a bell?
Yeah. We've been complaining about, there was this one developer we had that had stored it all, in his like config files in his home directory. So I'm really concerned about that as we move towards Kubernetes.
Yeah, well, that doesn't sound very cloud friendly. We already had some conversations with your architects regarding this. So it seems like you're using some sort of custom library that manages configuration in a not very cloud-friendly way. So this is something we definitely need to address.
Yeah, that's great.
So now that we have the different risks identified, then we have enough information to do an informed decision on what is the migration strategy that we want to follow with our application. So since we need to perform some changes on the application source code, I think the strategy here will be refactor. We will be changing some things. It feels like the only thing that needs to be replaced is the usage of this library. So I would say the effort for this would be small. And I understand this application is very critical for you. So I think the priority should be the highest.
Yeah, absolutely. This is the most problematic area for us.
Absolutely. So with that, we can submit a review, and it gets stored for us to consult it on it later on. So now that we have identified what would potentially need to be changed at a high level, I think we should get down to the detail within the application and run an analysis and try to find out exactly what needs to be changed and where.
This is great. Yeah, no, I wish we had this back when we were strangling out the gateway and order service and inventory service. Seems like it could really help us understand, the risks around this. So now we're going to dive into the customer app itself and analyze the code. Yeah.
Absolutely. For that, we have the tackle analysis module. We would definitely love to have it fully integrated with the application inventory, but that's not the case right now. So in the future, what we expect to have and what we're working towards is to, in the same way that I can choose an application and start the assessment like we saw before, be able to do that with the application source code or binary analysis. For the moment, it's not there. So we will have to switch to another application.
Nice.
But it kind of looks and feels the same. In the future, we will have it fully integrated. So the first step that I will have to do, just 1 second while I scroll across my storyboard. The first thing that I would need to do will be to create a new project. Again, this is something that won't be necessary in the future. The idea is to be able to launch the analysis right from the application in the application inventory. So these steps shouldn't be necessary in the future. Next, I will be uploading the application binaries for the analysis. This is another thing that will be changed in the future. We're currently working on having the application inventory and the tackle analysis bit to be integrated with source code repositories and also binary repositories like Maven corporate repositories for this tool to be able to gather the binaries or the source code directly from the source rather than having to manually upload everything.
Nice. Okay, great.
So for the moment, we have to do it manually, but this is just this is something that will change. So once we have the application uploaded, now it's time to choose the target migration path that we want to follow. So I have been told that you want to keep the Tomcat runtime that you have right now.
Yep, yeah, that's correct. But yeah, so I think we just want to containerize and you could do OpenJDK on here too, yeah?
Yeah, absolutely. So first of all, let's remove. It looks like I wasn't able to sell you this very cool application server called EAP, but whatever. So we will focus on containerization. Since I don't know how many migrations has this application being involved in, I will also check the Linux migration path just to make sure there are no Windows paths in there that might give us some trouble during the migration. And yeah, you mentioned OpenJDK. Are you willing to get rid of Oracle JDK?
Yeah, that would be great. I really can't afford any more Oracle in my environment.
Okay, so we can choose that.
And one last thing, it looks like I could actually, in the future, use this for those Spring Boot apps to analyze them if I wanted to move them to Quarkus. Yeah, that's kind of nice.
Absolutely. Okay. Some of the service, I noticed some of the service that you have still run on Spring Boot. You can use this tool to make the migration towards Quarkus as smooth as possible.
Great, thank you.
Okay, so now we have chosen our migration path. It's going to be containerization, Linux, and OpenJDK. We can move on. Next step will be to choose the packages that are going to be analyzed during this analysis, just to save time during the analysis and focus on what we need to transform. So I'm choosing this io.conveyor package. It's crazy. You use the exact same packaging that we do. So it kind of makes me feel like this is some sort of stage marketing demo, but it isn't it?
No, this is absolutely 100% real.
Okay, cool. So I chose this. We can move on. Next thing is one of the most important things for you to see during this demo, this non-stage demo. So as we were discussing before, we had a conversation with your architects, and it seems you have some problems with one of the libraries, the custom configuration library. So that's something that we definitely want to remove from the application. So what we've done in order to find exactly where this library is being used in the source code is to develop a custom rule for the analysis.
Okay. So basically, it'll catch environment-specific things that my architects have highlighted and identified. Yeah.
Exactly. That's
Okay.
that's exactly the case. So allow me to upload the custom rule. It will be corporate framework config. So the tackle analysis is based on a rules engine, and it comes with a very comprehensive set of rules. But if you need to customize the rules to try to find something related to your organizations, you can always expand the rule set with some custom rules, which is the case here. So I uploaded the rule, now I enable it, and this rule will be included within the analysis, and this rule will show us exactly where we are using this configuration library in your source code.
Very
Moving
nice.
on, we won't be using any custom labels. Loading. So there is a gazillion options to fine-tune the analysis, but we will stick to the migration target that we have just to make things as easy as possible. And the last step is just to check that everything is fine, all the configuration that we've done for the analysis, and just save and run.
Okay.
So right now the analysis is executing. Once it is finished, I will be provided with a report pointing out what needs to be changed for the application to be migrated. So since I know you're a very busy person, again, I already executed the analysis in advance, and I have the results right here. So this customer project already has some analysis for this application. I get into the reports, and I first get into the list of applications that were analyzed during this analysis. It was just one application, so I choose it. And well, on the reports, there is a lot of information regarding technologies used by the application. I had something interesting here that I wanted to be technologies, blah, blah, blah. Well, forget about it. But the most important thing is the issues that have been found, the things that need to be changed for the application to run on the target environment. So we have this view in here, and it shows what's optional and what is definitely mandatory for the application to be migrated, and especially to run on the cloud, which is our case.
Okay, so I see the hard-coded IP addresses it found, yeah, and some of the legacy configs. That's the custom rule, yeah.
No, the hard-coded IP, it comes bundled with the tool. It has found that you are using some hard-coded IPs in some of your files. It seems like you're using some hard-coded IPs here on these persistent properties files. We also have something related to the file system and accessing some static paths within the file system. This seems to come from one of the libraries. Since we are running the analysis on a binary, all the package or bundled libraries are analyzed as well. And the last rule is the custom rule that we developed and we enabled during the analysis that finds where this custom library is being used within your code. So what it provides is a series of hints of how to perform the change, of how to actually remove this library and get a more standard approach for configuration management, just to allow the configuration to be externalized and adopt a more Kubernetes-friendly model.
Great,
and now
great.
you say something about
Oh yeah, sorry, yes. Like, so basically, so you're saying like I could start to use config maps in Kubernetes instead of storing things on my local file system, yeah?
Yeah, that's the idea behind this change, rather than accessing static files in the file system. So this is the hint that is provided, the guidance that is provided for the changes to be performed. But if we click on the class, we can get right away exactly on the offending line and see what needs to be changed right into your code.
Nice. Now, how do we go ahead and change this?
Yeah, the thing is that this is a web application, so we cannot access the code and change it right away from here. And well, it may be possible to use this as a guidance and keep switching between your IDE and this web console, but it doesn't seem convenient to us. So because of that, we developed a series of IDE plugins on the most used, on the most famous, on the, I don't remember the expression, I will figure it out, on the best IDEs on the market, and most popular IDEs on the market. And yeah, with these IDE plugins, what we intend to do is to make the life of the developers easier and transport these information right into their IDE and make it easier for them to perform the actual changes. So my IDE of choice is Visual Studio Code. And you can see here that I have the project already opened, the application, the customer's Tomcat application open as a project. So I will switch to the plugin view. And first of all, what I need to do is to do the analysis configuration. So I have everything in the same way as I had it on the web console, the cloud readiness, Linux, and OpenJDK as target migration paths. And I also added the custom rule that we used on the analysis on the web console. So I will be just ready to go and click on run, and the analysis will be executed. Since we're running out of time, or since we don't have that much time, I already run the analysis. So I can get the exact same report that I had on the web console right away from the IDE, and I could switch between the two, but that's not practical. That's what we said. So I have information on what needs to be changed right into my IDE. So if I keep digging down in here, I can see that my persistent config class has been detected as problematic.
Something that needs a change, yeah.
Yeah, and there is a couple of occurrences of this custom rule that we found. And if I click on it, it brings me right away exactly into the offending line and tells me what needs to be done. If I need more detail, I can click on the issue, view the details, and I will get the exact same hints that I would get on the web console. If I need to perform the change myself, I can get it side by side with my code and start changing the things. Since it is a very simple change, shall we start coding?
Yeah, let's go ahead and make the change now.
Okay, so we will be using the property source annotation from Spring to make things a bit more easier. So this is where the configuration file will be loaded from, and the information from that configuration file will be dumped into an environment variable from the Spring environment class, and this is what will be accessed by the source code to load up the configuration. So I have this on here, and yeah, I definitely need to get rid of the different occurrences or calls to my library. I will get rid of this. I will get rid of this. And something is missing. Okay, this config. Okay, I can rename this environment variable to config. And let's organize the imports and see if this thing works. Okay, I want to use this class. And everything compiles.
Great. Wow, so basically you took me from being able to kind of assess my applications at a high level down directly into analyzing the code, all the way to making a change for not using local storage and now moving towards using config maps.
Exactly. So that's the idea behind Tackle. So assist you throughout the whole change process or migration process for your application, since from the assessment to the actual changes in your source code. But so right now, what we have is an application that can run into containers, but we haven't performed the migration itself just yet. So what we will need on the next step will be the different deployment manifest, the image. So that's something that the Move to Kube project can do. And my colleague Ashok here will explain some of these things right away.
Great. Thanks, Ramon. So now that we've had this customer application, we can actually start to containerize it. And Move to Kube can actually help us do that. But actually, I thought Move to Kube was really meant also for helping us move those services that are on cloudfoundry, that gateway and orders service. How does this work?
Absolutely, James. So the goal of Move to Kube is to speed up your process of creating the artifacts, right? Yeah, you have a lot of manual processes where you have to look into your code and then analyze, find the parameters, create your Docker files, your YAML files, and all of the parameters. So Move to Kube helps you automate it, whether it is in CloudFoundry or running in Tomcat. Right?
All right. I want to see it.
More?
Yeah, absolutely.
Okay, so let's dive into it. Okay. So let's consider for a moment that this is your repo. I have just cloned your repos, and let's see what's in.
All right.
I'm just opening them in VS Code. So here, this is your front-end application, and this is your backend. Your backend has multiple components, including the orders and gateway service, which are currently running in CloudFoundry. So what we want to do is to take this application and run it on Kubernetes.
Yep, exactly. Yeah. So basically, you have my source code now. What do you do next?
Yeah. Okay. For that, what we do is to use the MotorCube tool. Right now, I'm going to use the binary version of it. All I need to do that is I'm going to call MotorCube and then transform and then point it to this folder. And I have a config file which has some specific information about your deployment environment, which can be used by MotorCube. So I'm just going to point it to that. Okay, and up we go. So then we let it run. Okay. What it does now is it actually goes through each and every folder, every file, tries to find whether it's a project it understands. For example, you had the Spring Boot applications and Node.js applications. It tries to find each one of them.
Okay, got it. No, I see. It's actually, does it say it's planning the transformation? What does that mean?
Yeah, so it's going through each file and trying to figure out, okay, now it says it has detected a project in pattern flag. Similarly, it will go and find the other things. So it's going to have a plan, which will then be used to translate.
Okay, so you're actually going to be able to generate a plan for how you're going to create all my objects that don't exist in the concepts that don't exist in Spring, in cloudfoundry. You're going to be able to create those in Kubernetes for me.
That
so
is
things like, so if like ingress routes don't exist in cloudfoundry, somehow you move to Kube can figure out how to make those for me?
Exactly. Okay. So what it has done now is it has created exactly those artifacts that you mentioned, like your Docker files that were missing in your cloudfoundry, the deployment YAML, the service YAMLs, ingress that were all not necessary in your cloudfoundry but required for your Kubernetes. It creates all of them for you so that it is just a one-click deploy into your Kubernetes environment.
Really cool. All right.
So now let's see what's there. What it has created, right? So I'm just going to open the My Project folder, again in VS Code. You can see 3 folders here, right? The first is the source, which looks very similar to what you had. What it has done is it has essentially instrumented your source code with additional files. For example, it has added this Docker file for your Node.js application. Similarly, it has added the Docker file for your gateway application and your orders application over here. Right? So once you have these artifacts, you can then deploy it to Kubernetes. Right. So
okay.
With these Docker files, you can containerize. Right. The next step is to build these images. You have the scripts to build the images. I've already built to save time for us, and I've also pushed to register. The next step is to actually get the YAMLs and deploy. And as you can see here, inside the YAMLs folder, it has created your deployment artifacts, your ingress artifacts, and the services for all the 3 components.
Nice. Okay.
Okay. Do you want to see it running?
Yeah. So you could just deploy those YAMLs and we'll be off and running, huh?
Yeah, absolutely. So let's just look at the ingress once, and you can automate all the custom translations with MotorCube too. In this case, I'm just adding some annotations. And then what we are going to do is to deploy. To do that, we're going to do kubectl apply -f and into the My Project folder, deploy YAMLs. Okay, I'm just going to deploy to this folder. What I have already done is I've done log into your cluster, so it's already configured and set for this environment.
Okay, so earlier you logged in already.
Yes. Right. Now, as you can see, it has created the deployments, services, and ingress. Let's see whether they are all up and running. Okay, so the pods are all up and running, and the next thing that we will do is we'll look at the ingress. Okay, are you ready to see your app up and running?
Yeah. So I want to see it. So it's already running on Kubernetes. It's redeployed. Huh? Let's browse to it.
Exactly. So this is your app ingress URL, and I'm just going to head to your terminal. And I had I'm just going to go to that URL, right? As soon as I go there, you can see that the different tabs are there, the customers tab, products tab, and we can even check your
Nice.
backend. So this is your gateway backend
Oh, cool.
and the orders backend.
Wow.
As you can see, all of them are up and running.
Cool.
So
Cool.
what we have seen now is take the artifacts that are originally there and then add artifacts to it, including your YAMLs, Docker files, and stuff, and deploy it.
Wow. Wow.
But
Awesome.
you won't generally be doing this in your day-to-day environment, right? You would want to automate it, don't you?
Yeah, exactly. Yeah. Can I automate all this through so that I can deploy via pipeline?
Absolutely. So if you notice the artifacts that MotoKubevirt generated, you have the CI/CD folder. So it can essentially take the contain Docker files and automatically update the containing images as soon as you see a change in your Git repository. So all you need to is to just fire your change into the Git repository, and everything is automatic for you. It will automatically push to the container registry. Similarly, you can also deploy using Argo CD and other components.
Nice. Great. Great. Thanks, Ashok. This is great. Anything else on this, on the Cloud Foundry piece?
Yeah, I think that's mostly it. I think you have your database and other components to migrate to.
Oh yeah, that's true. Yeah, so that's interesting. Let me get back to where we're at in our journey here. So thanks for that. So that's an amazing way to be able to take all my Spring Boot stuff that was running on Cloud Foundry and get it deployed onto Kubernetes. So now I have, my gateway, order service, customer service, and front end all running on Kube, and I was able to get that running. But we kind of forgot one thing, I think, which is this Oracle database, right? We were talking about rehosting this Oracle database, and we never did that. So my customers app needs its database back over on Cloud Foundry as well. Miguel, what do we do here?
So, well, you see that depending on the architecture, some workloads are more containerizable than others, or more ready to be in containers than others. And this one is the one that probably will take the longest, and it will take more care to bring it into Kubernetes. But there's many benefits to bringing it into Kubernetes. Like, for example, being able to use the same networking for containers and the database. So why can't we bring it as a virtual machine? Well, luckily, we can.
All right, show me how.
There's this kubevirt capability in Kubernetes that enables you to run VMs in pods instead of containers. So you could simply manage your VMs with the Kubernetes cluster capabilities, but in Kubernetes. So the thing is that we have this vSphere environment. We have the database here. We want to migrate it. We need to use a tool. We have forklift tool. You can see forklift. I'm using this in this case the downstream version, which is migration toolkit for virtualization, but it's the same tool. So what we're going to do is we have providers, source and target. So where do we have the VMs? In the source, VMware. So we could add a provider. It will be very easy to add a VMware provider. We just need to add the name of the provider. So we could simply do it here and add the IP address or the name for it, and add the username, the password for the username, and the fingerprint to ensure we are connecting to the right provider. So once we do it, it will get connected. It will check the status to see if the connection goes well, the validation goes well. We can retrieve the inventory and check, for example, how many hosts do we have available, and even being able to select the migration network where the traffic is going to go to move the disks, so we don't impact other workloads. So we have the target, the source provider. Now we need the target. This is what we need. So we have here the current environment where this tool, forklift, is installed, and it's already configured for me. So one step less.
So
what do I do?
So you deployed forklift in your Kubernetes environment, and then you point it back at your vSphere environment, and then it's going to bring that VM over?
That's exactly it. So
Okay.
this is one. This is installed as an operator on Kubernetes. So you just install the operator and you access it, and then you're good to go.
Nice.
So we can create a migration plan to migrate. So first we give it provider name, so we can create Globex retail plan to migrate the retail database that you have in Globex. We have to select a provider. So we select this one. That is where it is hosted, and the target, we select the only one that we have available. And then we need to select a namespace. So I can create one by typing it, but I already prepared one, which is Globex retail. For the migration, I could go next, select the cluster where we have the VM, next. And then you see that we have several signs in the VMs here. This is because they have been checked before being migrated. So in this case, if there's any issue like the name is not valid for the target, I mean, Kubernetes requires RFC 1123 names, and this one doesn't have it. So we don't want to have issues. So we check as many things as we can before running the migration. So let's check for the VMs that are Globex in this cluster. And we have, for example, the retail database that we want to migrate. We have we have a business rules also for retail that we could migrate, and we have an enterprise service bus for Doomsday project that maybe it's interesting for you to migrate, but at some other time. So once we select this, I could go next, and then mappings. Okay, so we have several resources attached to the VM in the source that we want to have the equivalent in the target, and we have to establish the equivalence. One of them are networks. So I can create a network mapping by choosing the VM network in the source and assigning the equivalent in the target. This means also that we need to configure the networks in the target beforehand, but that's pretty straightforward. You do it only once to prepare the target for the migration, and that would be it. So once we do this, any VM that we have in the source connected to this network will be attached to the target network once migrated. This means that we could do the migration for hundreds of VMs instead of for one. Same thing for storage. Yeah, you were going to ask something?
No, this is great. It's very helpful. Thank you.
I'm glad you're liking it, Hank. So we could do the same. In this case, I have already prepared a storage map. So we have to have an equivalent storage in source and target. So the I/O is more or less the same, and the workload will behave more or less the same. So it becomes predictable, the migration. So once we have established the mappings, we could select the migration type. It could be cold migration, means shutting down the VM, copying the data, powering it up, or warm migration, which means you could start copying the data while the VM is live.
So it'll shorten my downtime window, yeah? Yeah,
that means that one, the downtime for the VM is lower, and second, you could migrate more VMs in the same intervention window.
Yeah.
So in this case, we don't have change block tracking, which is a requirement for this to run. Again, we're checking everything. So we need to perform a cold migration. Could go next. We could automate some tasks in source and target, like, for example, adding the QEMU agent for the VM. So it is running. I could click on next, and then I have the plan prepared. So I know it shows critical here. Okay, it was just showing you the plan, but we already run the plan for you because you're a busy man, and we already completed the migration. We have the VM transferred and completed. It took us 20 minutes because they are on different networks, and we had to go through a quite not fast link. But I mean, normally it would take like around 5 to 10 minutes each VM. So we transferred the disk. Everything is ready. I could see the VM running in the target.
Wow,
so if I access the VM, you see it's running. We are gathering already metrics from it, and I could go to the console and access it. But this is the interesting part. I could go to the environment, and I have attached a config map. Okay.
Okay.
This config map, I define it here, and I could change it from any GitOps environment, any GitOps environment that you could have.
So the same way I externalized my configuration from the customer app earlier with Ramon on Tackle. I'm doing the same thing with my VM here, so it's more GitOps friendly, yeah?
Exactly, that's exactly it. So in this case, we are running a tiny service in the VM that is going to mount this and run any script that we add here. So we could automate the initialization
database
of the
changes.
Database.
Yeah. Cool. And now my developers are going to be able to move a lot faster, right? Because now they just do a git push, and I can make database changes, yeah?
That's exactly it. And the second part is that once we have the VM in the target, we could clone it and be able to run it in Tecton pipelines and be able to test against an instance of this VM without having to disrupt the service at any time. And developers could run it without having to make a request
That's awesome.
to operations.
I like it. I like it. Very cool. Thanks, Miguel.
So I hope this helps on your journey, Mr. Scorpio.
Yes, please
modernize.
call me Hank.
Okay,
Hank. So that's great. So now we forklifted our Oracle database over to Kubernetes as well. That leaves one thing left. So Marco, this app that we were talking about with this inventory service sitting over on Kube, how am I gonna get that over here with Crane?
So let me show you.
All right.
Oops, sorry, wrong button. Give me 1 second. So my inventory application was manually deployed, right, as we said at the beginning, and as some environment-specific information into those deployment manifests, and that's what we want to clean up with Crane. So first of all, we're going to export this app that we have right now running and it's running in the inventory-source namespace. So we're going to use Crane to export all the manifests and to put that into an export folder. And then using another Crane command, which is the Crane transform command, we're going to generate a bunch of, like Crane will detect automatically what needs to be cleaned up using a bunch of plugins, and will create a list of JSON patch files that can then be applied later so that we can review them and making sure that everything is correct. And but the Crane transform command will, first of all, let's look at the export folder, right? So here I have all my YAML definitions, all my Kubernetes manifest in that folder, and the Crane transform command will do all the magic. We'll do all the cleaning, and we'll remove like the service cluster IP address information, the metadata information that was like that actually needs to become generic, because in a nutshell now I just want to clean this up so I can push that to Git and then follow our GitOps.
Okay. So anything that's like static or manual to an environment, you're going to extract that out so that I can redeploy easily.
Yes,
right?
that should all be automated, so that and only be included once we deploy to a specific cluster. So then our applications become really hybrid cloud and can be deployed on any cloud or any cluster from a generic point of view in a fully automated manner. So this is what the Crane transforms will do, and that will create, as I was saying, another folder with a list of patches. So if I look at my transform folder that got generated, so here I have the JSON patches that can be reviewed and stored and for audit purposes if I need to in the future. But let's assume that this is all actually correct now, and then we want to apply those patches to our original manifest and then push that to Git. So then I'll use the Crane apply command, which will then push like my cleaned up manifest to this inventory production folder in Git. And then if I go to this Git folder here, I'll have a resource folder that includes now my brand new manifest, all cleaned up and ready to be fully automated from Git using Argo CD.
Nice.
So one more step I need to do is to add this to obviously to my Git repo and to commit the changes and then to push that to my Git server. So now this is all in Git. I'm ready to go. So in the future, I can just make any changes to those manifests there and push that to Git, and Argo will keep picking them up and just make the changes for me. And again, this is all then becoming fully auditable, and I can roll back if there's any kind of issues with my deployment and so on. So there's a lot of benefits in using the GitOps model this way. So before I can now launch this into from Argo, the only last step is this is a database, right? And there's also there's a PV with data in it, and this is our inventory databases. This is all our products information, and so that data also needs to be copied to this new cluster where I want in my inventory prod cluster where I want to provision this application now. So this is where I'm going to use the Crane transfer PVC command, which will look at the source PV file, PV data, and then transfer that to my new PV location. Here in this case, I already did that because obviously we have a very large database with all our products. I'm not going to run this again, but in the nutshell, this is using rsync in the background and can be run multiple times, and we'll just keep copying the delta until you're ready to your final migration, right? And that can reduce the downtime and so on.
That's good because we have billions of things in our inventory.
Yes, so this is important data for you, but now we're ready, right? Like this data, this PV has been copied over, and we're ready to launch Argo CD. So here I have my Argo file, which is the definition of where I want where's this Git repository with my new Kubernetes manifest, and what the application name will be, and so on, and which namespace I want to deploy to. So I've defined in this Git YAML file, in this Argo YAML file, like what this deployment is. And now I'm ready to launch this for the first time and look at the fully automated way of provisioning your apps. And as you see, it will be very simple then to redeploy that to any cluster, as now everything will be fully automated. So let's launch the Argo application, and let's look at what this looks like in the Argo UI. So give me one second now to go to the Argo UI. And here you'll see my Argo application with the website, where you'll see my inventory production app that is now fully getting deployed automatically. If I click on it, you'll get all the details of all the Kubernetes resources and manifests that were executed, and attaching this to the PVC.
There's the PV, right?
Yeah, so now we just have to wait and for Kubernetes to provision all this and attach all the pieces together. This only takes a few seconds. And now I'll have a fully automated deployment to this environment. And from this point on, I can just make changes to Git, as I was saying, and push that, and then Argo will keep picking this up. So now I have a full CI/CD pipeline provisioning this application, and a fully automated way to also promote from dev to QE to production.
Okay. Wow. Awesome. That's great. So now basically my ops teams can't, complain. I'm deploying via GitOps. I can, easily redeploy this application over and over again and move my persistent data around between clusters. Yeah.
Exactly.
Cool. All right. Thanks, Marco. So between all these projects, let me see. I think we've actually gotten to our end state. So now, based on what you all showed me, I'm pretty confident that we could get to this end state, basically running our entire app on Kube, having more of a GitOps-based deployment model, running on a single platform. So of all the tools you guys just showed me, so these are, this is how it laid out, right? Between rehosting, replatforming, and refactoring. These are how the tools in the Konveyor community helped us today, right? They helped us rehost, replatform, and refactor our application to Kubernetes. In the future, we're going to be adding Polaris to this as well. If you're interested in joining us, we're at konveyor.io. We'd love to have you join us. You can subscribe for updates there. We're on #Konveyor on Kubernetes Slack. You could learn more by joining our meetups, which talk about a lot of these topics and other topics related to migrating and modernizing apps. And if you want to propose a talk, you could do so there. So thanks for joining. And with that, I'm going to stop the recording.